All right, I'd like to point out what this architecture is all about. So first and foremost, what I'm calling this is the EC2 plus CodeDeploy architecture for Docker-based projects. Now, that it is Docker-oriented is a little bit unique because there are lots of other container runtime implementations out there and architectures, but the main emphasis here is all about simplicity. So let's talk about some of the advantages of this architecture in general. And what I want to say about this, the main themes of why you might want to consider this is that this is a simpler production-ready deployment process in comparison to Kubernetes. Kubernetes has a lot of components, and they are very well designed, mind you. But what I think the main challenge is that for startups and small organizations, that's a lot to manage for maybe one or two DevOps engineers. And as such, it's not really practical for most production applications. And so when you're taking a look at this architecture here, there's not really too many moving components in the layers here. You start out with a base EC2 image. So you're going to create a golden image, and that will include your baseline operating system. So if you're in AWS, you might choose to work with Amazon Linux. The advantage there is Amazon's done a very good job of constantly maintaining the security profile of that. Or you might prefer Ubuntu because they have a wider array of base packages available to choose from. In any case, with this architecture, because the quantity of dependencies is so minimal, you may lean towards Amazon Linux, really up to your preference there. Then we install the CodeDeploy agent application in there. So that's a process that's running that communicates to the CodeDeploy service and receives events and acts on those. We'll install the Docker application in there. That's the ability to run containers, and then any ancillary apps and tooling you might need to facilitate managing that application. So for example, on some of the instances that I run, I have a SSH automation process. So that way it fetches keys every hour and when an instance boots up to ensure that anyone on the team can have keys and also be able to remove access from a system using a shared username. It makes it really simple. That way you don't ever have to worry about user permissions. And then finally, the architecture involves the containers that are actually running. And that then, of course, is your application. So you might have a single container per instance, or you may be running multiple containers per instance. And you could also, even if you wanted to, run supervisor D to watch that process, but Docker has the restart when argument, so you can rely on Docker to do the automated restart of instance processes for your application. And then, so the main advantages when I'm thinking of this architecture is really that the ops team has a clear focus when something breaks. So in comparison to Kubernetes, where you have like an ingress controller, you have networking layers built in, you maybe have additional security mechanisms built in either on a private network or a public network. All of those complexities can result in a lot more time spent debugging a Kubernetes implementation. So in contrast here, what you're working with here is basically vanilla Amazon or AWS architecture here with some unique bits, which are really just in the uppermost layers of your application that makes it unique. But being able to validate connectivity from instance to instance, being able to ensure that your operating system has the baseline packages, being able to ensure that you have the CodeDeploy agent on there and that your CodeDeploy succeed can all have tests built around them, including that Docker runs is capable of doing that. And then the remaining elements that you might need to debug are, say, an IAM policy that the instance can actually access an ECR repository or a Docker login if you're using Docker Hub. And then finally, just that your containers are resourced correctly and sized correctly. So it makes it very easy for an ops team to manage this. I call this really like, this is a lot of bang for your buck as far as an architecture goes. So let's kind of talk about what some of the responsibilities of the app developers are. And it's that they're going to create a Docker file for the application. And the advantage here is that the developers don't really need to care so much about the deployment endpoint or how it's getting to production, rather that they have a Docker image that can run. And then a convenience you can do in your deployment process is create these .run.sh scripts. Now, of course, you could call the Docker run commands directly, but if you're running more than one container or there's idiosyncrasies to how it starts up, having a single entry point for starting the application on your AWS EC2 instances is helpful. And then the developers should know how long each step should take, because in CodeDeploy, you want to set timeouts that are appropriate for rolling out code. And then, of course, they should understand how ports in the application are allocated. So a web server might only need TCP port 80 or TCP port 80 and 443 if it's responsible for doing SSL termination. A VoIP application, on the other hand, might have one port open, or it might have swaths of ports open. So for example, if you're doing voice communication, you might need UDP port 10,000 through 20,000 open on that instance. And then of course, the developers should understand their application's dependencies. So if there's databases, a need for shared file storage or anything like that, they should be able to understand that and be able to communicate that to the ops team. And then the ops team has a lot more responsibility in terms of the actual go-to-market, if you will, of our application. And that's all of your typical stuff that you need to know when you're launching an instance. But of course, you're going to need to subnet the application and its dependencies, set up security group rules, ensuring that your web app server can talk to, say, a database server, that if it's a application load balancer, that it can talk to the web servers, maybe restrict access so it can't get public access, things like that. You need to find your load balancer, size it, set up health checks. And then you need to create that golden image that we referred to in the previous slide. You need to create launch templates. So that's everything with like how big the instance is, as well as any user data that's going to go in, IAM roles that are going to be attached to the instance or otherwise. And then you'll be needing to configure the CodeDeploy application and environments. I use the term environments, but they use the term deployment group. And then, of course, you're going to need to be on a recurring basis, updating the base image on some frequency, and then also validating that new image is working and in good condition before you roll it out to the environments. And then, of course, you need to decide on access, who can access the servers and what those roles are. This is kind of like a rough architecture, and yours doesn't necessarily need to look like this, but this is generally speaking what, say, a web application would look like. You have traffic flows into the load balancer, gets routed to a target group. This applies to whether it's layer 4 or 7. If it's layer 4, then everything's always going to flow to your auto-scaling groups. And then you'll have the clump of what I was describing earlier, which is you're going to have your Docker image running as a container on an EC2 instance defined in a launch template, being coordinated and sized via auto-scaling group, residing inside one or many subnets for availability zones. And then that might be broken into, this would be on a per environment basis. So you'd have all this chunk repeated, maybe not the load balancer if it's layer 7, but then you'd have a production, a staging, and development environments. And then you may have a shared environment. So maybe you put your subnets, those might actually be shared, and all the environments share the same subnets, totally up to you. And then that's all going to be sitting inside of an AWS VPC. And then from time to time, you'll be updating those base AMIs. So that's what this architecture looks like at a very high level. In the subsequent videos, we'll dive into actually building out this architecture so you can get a hands-on feel and see what this looks like.